Bismillahirrahmanirrahim. Hello everyone. So my name is Abderrahman Skiredj. I am a research associate consultant at OCP Solutions and a PhD candidate at School of Computer Science, UM6P. So first, let me briefly introduce you both the team NLP of School of Computer Science and OCP Solutions. So the NLP team do researches in broad range of areas related to AI, for example, NLP, computer vision, speech recognition, and cybersecurity. They regularly participate in international events and competitions and achieve honorable rankings. As for OCP Solutions, it is a consulting firm, subsidiary of OCP Group, focusing on delivering consulting services on modeling, analytics, transformation, digital transformation, strategic transformation. And at OCP Solutions, our mission is to model knowledge for sustainable impact. And rightly enough, the presentation is entitled towards a more inclusive and real natural language processing. So what is the context? The context is that the research teams that are leading the way in NLP are from larger companies, research centers and larger universities that have tremendous financial and investment capabilities, both in annotating the data and in investing in supercomputers. For example, here in the figure, we see that model sizes across time follow sort of Moore's law, which means that model sizes are increasing exponentially year after year. And this exponential increase in model sizes implies also an exponential increase in the investment to produce such models. So it has financial, environmental, and inclusivity impacts. As for the financial impacts, here, for example, let's mention some costs for a single train run of such big models. For example, the XLNet, to train for a single training run from scratch, it costs about $245,000. T5 model, 1.5 million, and GPT-3, 4.5 million. As for the carbon footprint, the XLNet costs about 5 tons, emits about 5 tons of CO2, which is equivalent to driving a car about 20,000 kilometers. As for T5, it's about 50 tons, and GPT-3 about 90 tons of CO2, which is equivalent to driving a car to the moon and back, which is quite high. As for the inclusivity implication, this creates high barriers for researchers to enter the NLP community. They need money, they need investment, both in data annotation and supercomputers. And also the other implication is regarding the representation of language. The majority of findings are in English, leaving other, for example, dialects with very less resources. So the presentation will follow the following outline. First, why NLP? Why do we care about NLP? Next, the prevalent way to do natural language processing. After that, some new paradigms for training language models. And finally, and also how to leverage these new paradigms towards a more green and sustainable natural language processing, and finally, the experimental results and contribution. So briefly, what is NLP and What is its context? Well, the context is that we have a tremendous amount of data that is, most of it is unstructured. And how can we leverage meaningful insights from it? Well, NLP has established itself as the go-to solution to extract these meaningful insights and to drive business values. For example, with NLP, we can do chatbots, search engines, speech recognition applications, and classification tasks. For example, here is some solution for customer relationship, which is a multilingual chatbot supporting Arabic, French, English, but also Moroccan Darija. We can use NLP also for business intelligence and strategic watch to extract meaningful insights from unstructured articles. Also for the social network monitoring, we can, for example, automatically classify users' comments as questions or complaints to prioritize or just noise to eliminate. Next, what is the current paradigm of NLP and why it induces such sustainability problem? Well, after 2017, transformers, which was revolutionary neural network architectures, have become the de facto standards in NLP. Transformers are novel architectures that learns over a sequence of data, and natural language is naturally a sequence of words. And the power of transformers they are highly parallelizable, and so they can leverage pretty well the distributed hardware, GPUs and TPUs. And also they can see and train on much more data in a very short time. Transformers proceed in two steps. First, the pre-training phase, and second, the fine-tuning phase. So the pre-training phase is the most costly phase. We basically give the neural network a very huge corpora of text, ranging from 60 gigabytes to 1 terabyte or more of data. And how does it train on this data? We randomly mask some tokens or some words in the paragraphs, and the model has to predict them from the surrounding words. So at the end of the pre-training phase, we have a model that have gained a broad language, a broad understanding of a language, and it is a contextual understanding, in the sense that the same word can be encoded differently with respect to its context. For example, the word play in play the piano is different from play a role. And after this phase comes the fine-tuning phase, because why we are doing NLP? We are doing NLP for some target tasks, for example, automatic summarization or chatbot or any other task. So we will fine-tune this pre-trained model on this specific task, and the fine-tuning is much less costly. So this is what we call the pre-training fine-tuning paradigm. However, even with the rise of increasingly massive models, the performance doesn't increase at the same scale. So in the figure, the x-axis is in exponential scale. So we exponentially increase the model size, but the performance only linearly increases. And this is unsustainable. So what are some other pre-training paradigms for NLP? So let's first forget about machines and concentrate on a human. How do we human learn a language? Well, for example, if I give you a medical document and say you, please, can you summarize this to me? The task will involve mainly three high-level skills. The first skill is the domain knowledge, because a doctor would very simply understand complex medical texts that a regular person would not. Also the language, the ability to understand and generate language, and also the ability to reason. And inspired from this human way of learning language, it seems much more natural to train models on a mixture of tasks rather than just a plain MLM task, a plain fill-in-the-blank task. And there are increasing number of research works that explored and are still exploring these new training paradigms of diversifying and scaling over the number of tasks, and the list is not exhaustive. For example, in May 2020, the paper Intermediate Task Transfer Learning take the large pre-trained Roberta model. So we have the pre-training phase and the fine-tuning phase, and the model inserts between them a pre-fine-tuning phase on some intermediate tasks. And what he have found is that when we use some well-chosen tasks, especially some tasks involving reasoning, the model is able to generalize better. In January 2022, the XC5 model introduces a new paradigm named the extreme multitask pre-training paradigm. It is a multitask pre-training and not a multitask pre-fine-tuning, so to differentiate between this and the previous article. And it shows that multitask pre-training is far better than multitask pre-fine-tuning, and also this multitasking improves the sample efficiency of pre-training. In February 2022, the article Fine-Tuned Language Models Are Zero-Shot Learners fine-tune very large language models on many tasks framed as instructions. So for example, if we take the task translation, we don't just give the model input-output sentence in English, its corresponding sentence in Arabic, but we framed it as prompts or instructions. We say, please translate this to me in Arabic, or how can we say this in Arabic? And framing these tasks into natural prompts or instructions lead a better generalization. Also, and finally, in October 2022, the very recent paper, Fluency5, it scales the number of instructions to 1,800 tasks and scales the model sizes from 8 billion parameters to 16 billion to 540 billion parameters. And also, as a third contribution, it's fine-tuned on chain of thought data, which is a very challenging task involving high-level abstractive reasoning. And they get very large gains. So how can we leverage these findings to achieve green and inclusive NLP? So our work is exploring these novel questions. Can we get similar performance for using this multitask pre-training paradigm in less resource setting with smaller models, less financial capacities, and less data? Always in this low resource setting, how about the scaling behavior of our performance given that we increase the capacities and we invest more? If we invest more, is the performance will go at the same scale or no? Or it is just a power law as the classical pre-training paradigm? Also, on the nature of training tasks, what are the best, what task classes benefit more for this multitask pre-training? Is the separation domain knowledge, linguistics, and reasoning, is this a relevant separation? Also, as a novel idea, can we get the most of our mixture of tasks by letting the model not only learn to answer our instructions, but also learn to to detect or to predict some masked words in both the instruction and the answer. And this way, it will learn both from the instruction as well as the answer. And how about the other languages, for example, Arabic and its dialects? Should they necessarily follow the same findings as for the English language? Well, probably not. For example, the Arabic language is very rich, very precise. For example, for a single word in Arabic, it can have more than 100 synonyms, and each synonym have a very specific meaning that only scholars in Arabic know the subtle differences. And also for the Darija, the Moroccan Darija, or the dialects in Africa, they are very versatile and changing, and they are multilingual. So moving to the experiments, we are exploring the raised questions in the case of Arabic language and a mixture of tasks over the three high-level skills: linguistics, domain knowledge, and reasoning have been curated. So with a total of 60 gigabytes of data, which is equivalent to the 60 gigabytes that has been used to pre-train the model RBERT, but here with a mixture of tasks. Well, the pre-training is on its way. It hasn't finished yet, but we have some introducing results. For example, let's focus on the linguistic part. While all recent advances in Arabic remove diacritics in the pre-training phase, we are exploring a novel method to take them into account. So first, what are diacritics? Well, in Arabic, we have letters, and we have optional letters that can be put on top of letters to disambiguate the meaning and also the pronunciation. For example, with just 3 words, if we change diacritics, we get different meanings. Is diacritication important? Yes, because it helps to do speech-to-text and text-to-speech application. It helps to understand difficult Arabic text, and it encapsulates very important linguistic features. Can we just go back, please? Okay. Yes, so the novel idea is, why not taking diacritics into account in the masked language modeling task by randomly masking words and or diacritics? So we mask both either words or diacritics, and the model will try to restore them, and this will encode this knowledge of diacritics. And in an attempt to prove the importance of linguistics in Arabic, we have targeted a very challenging tasks in a linguistic point of view. What is the task? The task is to restore the diacritics of a very specific classical Arabic texts, which is a collection of 5 diacritized books in Sufism, which is a highly mystical and spiritual branch of religion with poetry passages. And what is the approach? Well, we introduced a novel approach for diacritizing text using a fully word-level method, because recent and most advanced automatic diacritizers use character level or a mixture between character level and the word level, and this is fully word level, and so it is much more compute efficient. And so we have trained RBERT, fine-tuned it on the diacritization downstream task.
Excuse me, Abderrahman, I'm really sorry, but we have to
yes, we have finished already.
Yes, thank you.
Okay, and it has achieved a performance of 75, and we have now taken RBERT and fine-tuned it on linguistic tasks, and finally fine-tuned it on the downstream task, and now it achieves 86% accuracy, which is significantly better. So to recap and to conclude, we have mentioned the motivation for gain and inclusive NLP. The new multitask pre-training paradigms can be used in less resource setting, and we have experimented with Arabic NLP, and we have raised some questions for dialects. And thank you for your attention.
Thank you very much.